Today, we are going to discuss solving systems of linear equations with three variables using Cramer's rule. We are going to write first the matrices of d sub x, d sub y, and d sub z. We start with the matrix of d, and it is equal to, on the first column we have a sub 1, a sub 2, and a sub 3. On the second column we have b sub 1, b sub 2, and b sub 3. For our last column, we have C sub 1, C sub 2, and C sub 3. So this is the matrix of D. With this matrix, we can already solve the determinant. So we now solve for the determinant of matrix D. We have to cover A sub 2 and A sub 3, and B sub 1 and C sub 1. A sub 1 will be multiplied to the difference of the product of B sub 2 and C sub 3, and the product of C sub 2 and B sub 3, minus, this time we are going to cover A sub 1, C sub 1, B sub 2, and B sub 3. B sub 1, multiply it to the difference of the product of A sub 2 and C sub 3, and the product of C sub 2 and A sub 3. Added to, so we now cover A sub 1 and B sub 1, C sub 2 and C sub 3. C sub 1 multiply to the difference of the product of A sub 2 and B sub 3, and the product of B sub 2 and A sub 3. Now we are ready to solve for the systems of linear equations in three variables using our Cramer's rule. Example. Given system, we have x plus y plus z equals 2, 2x plus y plus 3z equals 9, and x minus 3y plus z equals 10. So we have to identify the values of our a, b, c, and d for us to be able to solve our determinant. So these values will be written in a matrix. So we identify the values of a, b, c, and d of our first equation. A sub 1 is equal to positive 1. Our b sub 1 is equal to positive 1. C sub 1 is equal to positive 1. And d sub 1 is equal to positive 2. A sub 2 is equal to positive 2. B sub 2 is equal to positive 1. C sub 2 is equal to positive 3. D sub 2 is equal to positive 9. A sub 3 is equal to positive 1. B sub 3 is equal to negative 3. C sub 3 is equal to positive 1. And D sub 3 is equal to positive 10. So we will now write the matrices of D sub x, D sub y, and D sub z. After writing each matrix, we will also solve already the determinant. The matrix of D is equal to 1, 2, and 1 for the numerical coefficients of X, 1, 1, and -3 for the numerical coefficients of Y, and 1, 3, and 1 for the numerical coefficients of Z. We now solve the determinant of matrix D. So D is equal to, we have to cover 2 and 1 and 1 and 1. We have 1 times 1 times 1 is equal to 1 minus 3 times -3 is equal to -9. Now we cover 1 and 1 and 1 and -3 minus, we copy 1 times 2 times 1 is equal to 2 minus 3 times 1 is equal to +3. We cover 1 and 1 and 3 and 1 plus, we copy 1 times 2 times -3 is equal to -6 minus 1 times 1 is equal to +1. One minus -9 is equal to +10 times +1 is equal to +10. 2 minus 3 is equal to -1. -1 times -1 is equal to +1. -6 minus 1 is equal to -7. -7 times +1 is equal to -7. 10 plus 1 is equal to 11. 11 minus 7 is equal to +4. So the determinant of matrix D is equal to +4. This time, we write the matrix of D sub X. The first column compared to our matrix D will now be replaced by our constant terms. So we have 2, 9, and 10 for our first column. Second column, we have 1, 1, and -3. And for the last column, we have 1, 3, and 1. We now solve the determinant of matrix D sub X. So D sub X is equal to, we cover 9 and 10, and 1 and 1. We copy 2 times 1 times 1 is equal to +1 minus 3 times -3 is equal to -9. Next to cover, we have 2, 1, 1, and -3 minus, we copy 1 times 9 times 1 is equal to +9 minus 3 times 10 is equal to 30. Next, we cover 2 and 1 and 3 and 1. So the next operation is addition. We copy 1, multiply it to 9 times negative 3 is equal to negative 27 minus 1 times 10 is equal to positive 10. 1 minus negative 9 is equal to positive 10. Positive 10 times 2 is equal to positive 20. 9 minus 31 is equal to negative 21. Negative 21 times negative 1 is equal to positive 21. Negative 27 minus 10 is equal to negative 37. Negative 37 times positive 1 is equal to negative 37. 20 plus 21 is equal to positive 41. Positive 41 minus 37 is equal to positive 4. So the determinant of matrix D sub x is equal to positive 4. The next matrix that we are going to write is the matrix of D sub y. The second column will be replaced by the constant terms. In our first column, we have 1, 2, and 1. In the second column, we have 2, 9, and 10. In our third column, we have 1, 3, and 1. We now solve the determinant of matrix D sub y. We cover 2 and 1 in the first column and 2 and 1 in the first row. We copy 1 times 9 times 1 is equal to positive 9 minus 3 times 10 is equal to positive 30. We cover 1, 1, 9, and 10. Our next operation is subtraction. We copy 2 times 2 times 1 is equal to 2 minus 3 times 1 is equal to positive 3. We cover 1 and 2 in the first row and 3 and 1 in the third row. Our next operation is addition. We copy 1 times 2 times 10 is equal to positive 20 minus 9 times 1 is equal to positive 9. Nine minus 30 is equal to negative 21. Negative 21 times 1 is equal to negative 21. 2 minus 3 is equal to negative 1. Negative 1 times negative 2 is equal to positive 2. 20 minus 9 is equal to positive 11. Positive 11 times positive 1 is equal to positive 11. Negative 21 plus 2 is equal to negative 19. Negative 19 plus 11 is equal to negative 8. So the determinant of matrix D sub y is equal to negative 8. And now we are going to write the matrix of D sub z. Compared to the matrix of D, we are going to replace the third column with our constant term. In our first column, we have 1, 2, and 1. In our second column, we have 1, 1, and negative 3. And for the third column, we have 2, 9, and 10. We now solve the determinant of matrix D sub z. We cover 2 and 1 in the first column and 1 and 2 in the first row. We copy 1 times 1 times 10 is equal to positive 10 minus 9 times negative 3 is equal to negative 27. We cover 1, 2, 1, and negative 3. Our next operation is subtraction. We copy positive 1 times 2 times 10 is equal to positive 20 minus 9 times 1 is equal to positive 9. Next, we cover 1 and 1 in the first row and 9 and 10 in the third column. Our next operation is addition. We copy positive 2 times 2 times negative 3 is equal to negative 6 minus 1 times 1 is equal to positive 1. 10 minus negative 27 is equal to positive 37. Positive 37 times 1 is equal to positive 37. 20 minus 9 is equal to 11. 11 times negative 1 is equal to negative 11. Negative 6 minus 1 is equal to negative 7. Negative 7 times positive 2 is equal to negative 14. 37 minus 11 is equal to positive 26. Positive 26 minus 14 is equal to positive 12. So the determinant of matrix D sub z is equal to positive 12. We can now solve for the values of x, y, and z using the determinants of our matrices D, D sub x, D sub y, and D sub z. The determinant of matrix D is equal to positive 4. The determinant of matrix D sub x is equal to positive 4. The determinant of matrix D sub y is equal to negative 8. And the determinant of matrix D sub z is equal to positive 12. We solve for the value of x, and it is equal to the quotient of the determinant of matrix D sub x and the determinant of matrix D, which is equal to 4 divided by 4. 4 divided by 4 is equal to positive 1. So the value of x is equal to positive 1. For the value of y, we have the quotient of the determinant of matrix D sub y and the determinant of matrix D, which is equal to negative 8 divided by positive 4. And the quotient is equal to negative 2. And for z, it is equal to the quotient of the determinant of matrix D sub z and the determinant of matrix D, which is equal to positive 12 divided by 4. 12 divided by 4 is equal to positive 3. So x is equal to positive 1, y is equal to negative 2, and z is equal to positive 3.